Good afternoon, students. Must be slowing down the video I'm making. I'm making it after 1 o'clock, and that's not my normal. But we're all struggling, I think. Keep in mind that I'm doing the lessons as scheduled and trying to put them up, and 95% of you are getting everything done. I'm very proud of you. Cannot explain how proud I am. If there's extenuating circumstances for individuals on a deadline, you need a few more hours, or something was glitching, I am working with all of you individually. And there have been some requests, and I'm here to help out, just like you're bearing with me that you didn't have this video at 9 o'clock this morning. I hope you're not too upset with me. It's called flexibility, and we're doing okay. We'll be done with this chapter next week. So you'll have a test next week. I'm not sure how I'm going to administer it. Got to get through this lesson and one more lesson. I'll probably give you a day where you do a practice test through my math lab, and we'll see how that goes. But for now, let's continue today's lesson. Almost finishing chapter 7. A lot of work was done here, I guess. And am I still recording? Oh yeah, I'm still recording. We're doing 7, 6, not graphing, solving trig equations. Have fun, guys. Take your time this weekend. Your homework is due on Monday morning, okay? Bye, guys. Miss you all. The lesson is trig equations, okay? Now, trig equations are just an equation that has a trig function in it. So it is something as simple as sine of x equals to 1. It's easy to solve because you're looking for x. What must x be? And since there's only one value, where sine is equal to 1, and that's located up here, you could call this 90 degrees. Or if you're in radians, you would say pi over 2. There's only the one answer. What if I said to you sine of x equals to a half? Well, most of you have your basic trig functions now memorized. And so if we're doing this one, how I would look at it is that's a positive over a positive. Where is sine positive? Up here. And that means there could be two answers. You could have one answer here. You could have one answer here. And if this is my x, my angle, and sine is a half, well, then you wouldn't be surprised to see me write that out. Or if this was x, which is a reference angle for that full, wrong color, I want you to see it. This angle, using that reference angle, that's bigger than that angle here, but we still use the 1 over the 2. Hopefully you know that that's 30 degrees. Both of those x's would be 30 degrees. However, you got to be careful because, yes, x is 30 degrees, or x is pi over 6 if we were doing radians. But what would this angle be over here if this angle's 30? That angle still is 30 degrees. Well, you take the 180 and you subtract that 30. That gives you, then you are looking at x is 30 degrees, or x is equal to, let's see, if I'm taking 30 degrees from 180, that's 150 degrees. And of course, in radians, let's see how I would do that. 30 degrees, 60 degrees, 90 degrees, that's 3. 120 degrees, 150 degrees. Well, that was 5 of them. 6 of those would have taken you to the 180. So 5 pi over 6 would be the other answer. So those are basically trig equations, but of course they are the most simplistic ones. And you can imagine some of these start from so ugly. All right, now there's 2 things to pay attention to. He's asking us for degrees, and what's the other thing is? I forgot what I was going to say. We're in degrees. We're only going to want answers from 0 to 360. That means all the answers you would get from 0 all the way around. And you know there's more answers because you could take every answer you get and go another circle around and get more answers and more answers. And I think that is one of the examples he brings up. How would I do this one? I need to isolate sine of theta. So I hope you see that sine of theta would be a negative half. Oh, okay, well, we just did a problem just like this, but now we must have sine to be negative, and where is sine negative? Down here, because the y value is negative. So the 2 can never be negative because that's the hypotenuse. So the 2 isn't going to be negative. Must mean that opposite of this angle must be the negative 1, which makes sense. The y values. And that, again, is a 1, 2, square root of 3 triangle. So that must be a 30-degree angle. However, let's see. It could also be x could be, why am I saying x? He used theta. Theta could be a negative 30, or theta could be, if this is 30, then 150 plus 30, 180 plus 30 must be a 210. Theta could be 210 degrees. Or if I take 360 away, take 360 and take the 30 away, that could be a theta, could be a 330 degree angle. But since he limited my domain, or the interval, to be 0 to 360, I wouldn't use the negative 30. Even though it is true. It is true, it is a negative 30 as well. But if you used your calculator and did the same thing, plugged it in, if you were to go 2 times sine of a negative 30 plus 1, it should give you 0 in your calculator. Likewise, if you plugged in the 210, 2 sine of 210 degrees plus 1 should also be 0, and so forth. So you got a lot of things to pay attention to. Let's see if we're right. This is him solving it. This is him telling us what quadrants we would be in. The reference angle was 30 because sine of theta, okay, the solution set. Those are his 2 answers. Okay. Now look what he said right here. To find all solutions, in other words, not just restricted to this domain, you would have to, I think we're going to do that, you would have to realize, well, if my first answer was 210, I could go all the way around from this point here, 360 degrees. 360 degrees plus 210, I could get another one. That'd be 570 degrees. I could go around again plus another 360 and get another answer. Now, if I go with this 300 degree angle, I could add 360 to that. 760. Add 360, I don't know, what did I say the answer was? Was 360 plus 210, no, plus 300. 660 plus another 360. That would be 1020. So you have a whole lot of answers if we wanted all solutions. But there might be a better way of saying those answers. We could just say that theta will be, let's see, 360 degrees times how many times you're going around plus the 210. So you go around once, up more. You go around 2, you go around 3. I think that'll work. The other one was theta. Theta could be 360 times the number of times you go around plus the 300. Because you always have that 300. Then you got to add 360 plus another 360 plus another 360 plus another 360. So that's your generic answer for all possible answers. But normally we don't deal with all possible answers. We just deal with the ones that go from 0 to 360. Sometimes they'll go, negative 2 pi to 2 pi or negative 360 to 360, and you get some answers. But in real life, we just stick around the one time. Okay. Yep, there it is. 210 plus 360n, 300 times 360n. N is any integer. Good. New problem. Now, these problems get harder as we go. The advantage is you can always stop. You can always replay it. You can always look at the answers on the slides that you have downloaded. You can also Google another video on solving trigonometric equations and find some more problems. You do have a lot of power at your disposal. Okay, how would I solve this equation? Well, you can't solve an equation unless everything is on one side. Why did I rewrite it? It's already written right here. Hello. I need the room, so let me... it's bad enough I have infinite white space, but I still want more room. We always want more. Get it all on one side. So I'm going to put the sine of theta times tangent of theta, subtract sine of theta. Now it equals to 0. You always have to get everything on one side. Please don't be... I'm going to show you, I think he even brings it out, about a common mistake that gets done. But let's check this out first. Now that you've brought everything on one side, the F word has to be in your vocabulary. As always, factoring, factoring, and factoring. What can I factor out? I could factor out a sine. That leaves the tangent minus 1 equals to 0. So now you have, just like when we did quadratics, when we factored a quadratic equation, you always had the two factors. This could be equal to 0, or this could be equal to 0. So those are your two possibilities. It really is your two possibilities. Where is sine equal to 0? Well, that's good news. Sine equals to 0 can occur two places. Remember, we could have it here, or we could have it here on that unit circle. And what are we doing, radians or are we doing degrees? He's doing degrees. Okay. This would be 0 degrees. This would be 180 degrees. So just for this component alone, theta could be 0 degrees or it could be 180 degrees. Now let's do this component. That means tangent of theta minus 1 could be 0, which means tangent of theta could be a 1. When is tangent equal to 1? Think about it. Think about it. Did it ever happen on the unit circle? With this point being 1, 0, this point being 0, 1, this point being negative 1, 0, this point being 0, negative 1. Tangent is sine over cosine. Sine over cosine, y over x. 1 over 0, is that 1? No. 0 over negative 1, is that 1? No. 0 over 1, is that 1? No. Negative 1 over 0, is that 1? No. So it didn't happen there. Did it happen on a 30, 60, 90 triangle? 1, 2, square root of 3. Opposite over adjacent. Opposite over adjacent, is that 1? No. How about this angle? Opposite over adjacent. It didn't happen there either. Well, I know I've seen it before. What's left? Maybe the 45, 90? 1, 1, square root of 2? There it is. There it is. You see, if I take this 45 or this 45, it doesn't matter. Opposite over adjacent. It's a 45-degree angle. Theta has to be 45. But be careful. Is there 2 answers? Just like there was right here? Back to my unit circle. If one of my angles is 45, which I think we agreed, 1, 1, square root of 2, well, where else is tangent positive? Is tangent positive down here? No. Because opposite would be a negative 1 over 1. Is tangent positive here? Let's see. If that's 45 degrees, that would be a negative 1. That would be a negative 1. Oh, it is. There's that angle here. Let's check the other one here. Is tangent positive there? That's a 1 and that's a negative 1. No, it's not there either. So it has to be these two. Well, all students take calculus. All students take calculus. It had to be these two. So if it's quadrant 1, that's a 45 degrees. If it's quadrant 3, then that would be 180 plus the 45. 180 plus 45. How much is that? 5, 2, 1, 225 degrees. So in this problem, theta can be 45 degrees, and it could also be the 225 degrees. So there's 4 answers to this problem. Keep in mind, most trig equations can have 2 answers. There he factored, set equal to 1, 1. He gave all the names for those things. 0, 180. Yes, we have them all. Notice how he puts all the answers in one set. That's a nice thing. I'll give him extra credit, plus 2 points, because he's so smart. Get our work. We had 4 answers. He put them in order here. 0, 45, 180, 225. You only got the 45 and the 225 answer. Is that what I wrote over there? You missed those two. Now, all right, here's the caution that I was going to talk to you about. That trying to solve the equation example 2 by dividing each side by sine of theta would lead to tangent of theta is 1, which we would get those two answers. What's wrong with that? Well, I can look. Always the fear when you divide both sides. What's wrong with that? If I take sine of theta times tangent of theta equals to sine of theta, and you didn't listen to what I told you about getting everything on one side and said, oh, I can just divide everything by sine of theta. Yay! Tangent of theta is equal to 1. And unfortunately, that only gives you two answers. That does give you theta is equal to a 45-degree angle and the 210-degree angle in this quadrant. Unfortunately, you lost two of the answers. If you go by something, why did I write 210? Surely I could take 180 plus 45 and do it correctly. That was 225. Hello. So that's a caution. Let's do another one. I'm looking at tangent squared plus tangent minus 2. Now, you may not see it, but I'm old and I've seen these before. This is quadratic. It's really no different than looking at x squared plus x minus 2 is 0. It's really no different than that, except x is really tangent of x, and later on that would be important. If x was really equal to tangent of x, that means every time I find x, it means tangent of that is something. So first thing I would always try to do, can I factor this thing? X minus 2 times, no, x plus 2 times x minus 1. X squared plus 2x minus x gives me an x. Yes, there it is. So when I solve that, you know that x can be a negative 2 and x could be a negative 1. Well, this is very good to simplify it, but it's not really what's the case. It is tangent of x is equal to a negative 2, and tangent of x equals to a 1. Now, this one I can do very in my head. Tangent of x equals to 1. We already did that problem. That was x was a 45-degree angle or a 225-degree angle. This one doesn't come from a special angle. It's not a triangle that I recognize, 2 over 1. It doesn't happen. So I'm going to have to pause, and I'm going to have to use a calculator. Oh, I made a mistake. Look, I didn't pay attention. He's in radians. Let me fix this up. Pi over 4, and that was 5 pi over 4. Because 45 degrees, 90 degrees, 135 degrees, 180 degrees, plus another 45. There it is. 5 pi over 4. Each of those is a pi over 4. So boom, boom, get rid of that. Get rid of the evidence that I didn't pay attention. This one, I'm going to use a calculator. And I'm going to show the screenshot. Okay? I'll paste it here. So get your calculator. Get ready. Because what I'm going to type in is the second function of tangent. That's arctangent of not x, of a negative 2. That's what I'm keying in. Make sure you're in radian mode. Okay, I'll meet you back here in just a second. You do it, and I'm going to do it. Okay, got my answer. Do you have yours? Make sure you're in radian mode, because I first did it in degree mode, and I had something like can't remember, was it a negative 100 degree angle, or I don't know, something like that. Anyway, let's look at it. The answer I got is x equals to a negative 1.1074. Radians, which we never record that. I just making sure you understand. Which tells me, now think about it. If I go all the way around the circle, starting here and go left, that's a negative 2 pi, which is a negative 2 times 3.14, approximately, right? Which is approximately negative 6.28. That's all the way around going clockwise. So if I go 1/4 of it, this would take you to a negative 1.5. 1.5, 3.14, and so forth. So I'm in quadrant 4 because I haven't gone past a negative 1.5. So we're in quadrant 4. Now, that's not a big deal, except that's one of your answers, except for he only wants us to go from 0 to 2 pi. So the question I would ask you is, where else is tangent of something negative? Tangent is negative also in this quadrant. So, yes, here's one of my answers as a negative 1.1074. But if I go the other way around the circle, and go this way instead, I got to find out what that answer is. And then realize if I keep on going in the positive direction, I have this answer again, but not the negative answer. Okay? So how am I going to work on that? Think about it. If I was here at negative 1.1074, how many radians is it to move this line all the way that way? It's a straight line. So that made 180 degrees, but I have to keep it in terms of radians. So my answer for this particular problem would be pi over 2 plus the original start where I was, negative 1.1074. Whatever that is. You pick up your calculator. I'm going to estimate it. Pi over 2 is roughly 1.5. And then I'm going to subtract roughly negative 1.11. So my answer is approximately 1.5. Why am I adding pi over 2? That's a pi, I'm sorry. Adding pi. it's 180 degrees. I know that's pi. Silly me. So I'm adding 3.14. Come on, right. 3.14. Okay. Now I'm adding it to the negative 0.11. So I'll do that scratch work here. 3.14 subtract a negative 1.11, 302. So that's one of the answers. Then if I'm already sitting over here at a 2.03 radians, to go to the positive angle here, I could just add pi again. So I'll take the 2.03 and add the 3.14 again. 7, 4, no, 1, 3, 4, 5, 5.17. All right, so my solution set. X is, my original answers I had was pi over 4 and 5 pi over 4. Pi over 4, 5 pi over 4. Now I'm going to take these two answers, my 2.03 and my 5.17 would be probably decent answers. Let me stare at it for a minute, make sure. It's a lot of work. Let's see. I'll forget what these are when I go to the next page. Here goes. 2 points. Hey, 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 hey. Oh, yay. Of course, I'm so happy. But look what I did up there. I wrote pi over 2 instead of pi. So, okay. Here's two of them. Next page. 7. Sorry, guys. He got a lot of decimals. I didn't want to go back to my calculator. 2.03, 5.17. Let's see, that's close. 2.03, 5.1. All right. I feel okay with these answers. Next problem. By the way, the ones we've done so far in real life are probably as hard as they ever come up in real life. If you understand these 4 problems, you are good for any trig equation we could ever have in calculus. The other ones they do in this section, sometimes they're on steroids. But if you love math, then you don't care. Find all solutions of cotangent of x times cotangent of x plus 3 equals to 1. Well, I have to get everything on one side. So that's cotangent of x times cotangent of x plus 3. Minus 1 is 0. I need to factor, but I can't factor because I have a minus 1 out here by itself. So I might have to distribute this cotangent of x in here and split it all up and then recollect and see what happens. Cotangent times cotangent is cotangent squared x. Cotangent times 3 is plus 3 cotangent x. And then I have a minus 1. Now it goes. Now, this is pretty beautiful. I don't know if you see the beauty in it, but guess what I'm looking at? I'm looking at another quadratic equation. Oh, look at this. He's giving me a hint right here. Using the quadratic formula. That must mean if I try doing it x squared plus 3x minus 1 is 0, it probably doesn't factor. Because the only terms that could go here would be a plus 1 and a minus 1. And the only terms that could be first would be an x and an x. And if you do x times negative 1 and 1 times x, they cancel out. You never get the 3x term. So it didn't factor. We would have figured that out. We're so good, My students at South Texas health professions are so smart, they would not have needed a hint to have seen that as quadratic formula. So since it's quadratic formula, A is a 1, B is a 3, C is a -1. And the only reason why I'm putting the formula down for quadratic formula is not for my students. It's for the whole world that I'm sure they're watching my videos. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. X equals to, now remember I'm pretending this right up here, but x is really cotangent of x. Don't forget it. But right now I'm keeping it simple. X equals to minus b minus 3 plus or minus square root of b squared, that would be 9, minus 4 times ac, ac -1, all over 2 times a, which is 2, is -3 plus or minus square root. 9 plus 4 is 13, all over 2. But remember what we said. X is really the cotangent of x equals to -3 plus or minus square root of 13 all over 2. I'll be honest with you, I don't know the answer. Even if this was tangent, I don't know this number. It is not a special angle. It's not on the unit circle as far as a special place. So this is a calculator problem. So I'm going to go to my calculator, and you're going to do it too. In my calculator, I would have to key in not second cotangent, because you don't have a second cotangent. You have a second tangent. And since you're doing the reciprocal of cotangent, you got to take the reciprocal of that, or 1 over this, which just turns it into 2 over a -2 plus square root of 3. So let's do it. I'll post what my screen looks like. I'll be right back. Okay, I'm going to need my, gave you some time. Now I'm going to load the picture. There it is. And let me explain to you everything I put in here. This is exactly what I wrote down. Arctangent of the reciprocal, 2 over -3 plus the square root of 13. But I also have to do 2 over -3 minus the square root of 13. Now this is one of my answers because it's in that range between 0 and 2 pi. This is negative. So I got to deal with that. So if I show you graphically what that means, let's see. If I have my quadrant here, and obviously the first answer was 1.27 radians. Remember what I said about pi over 2. Pi is 3.14. 1.5 is pi over 2. So my first answer is in this quadrant right here. That would be my first answer. That would be the roughly 1.276 radians. The other answer is below. So I'm going to put it in a yellow that you can't really. It's down here. It went this way. And since it's negative, negative 2 point, what did I wrote over it, I can't see it, 2.9, negative 0.29, did it again. Did I lose everything? I lost my page. There's my page. Okay, so that was negative 0.29. But my cotangent is positive, so I need to have the answer that's 180 degrees going counterclockwise. So that would take it up into here. How do I get the positive cotangent that's up here? This one's a positive cotangent. It's fine. This one's going to be my positive cotangent. What did I do with my negative 0.29? I added pi. And that rotated that answer up there. So I added pi. And so there's my second answer. So x is approximately 1.2767 or 2.8475. You can round it if you want. I saw in my math lab maybe a problem or two was asking for 6 decimals. That's ridiculous. AP Calculus, we only use 3. In AP Stats, we use 4. But 3 is fine. That's plenty precision. Let's see if we're right. This was a hard problem because it was an arc cotangent and we had a negative answer and blah, blah. Look. Did I write? Oh, man, I lost the page again. Arc second tangent. I did talk about that. Okay. Okay, there's my quadratic formula part. Oh, did I write down the? Let me go back. I lost it. I hope I had done the. Oh, I did write down the second cotangent there in my calculator. So, obviously I did, because how would I use my calculator? He did it a different way. He did his square root stuff. Then he did this. He left it as 1 over. I look at my notes. I did it a little differently, but it's okay. Did we get the same answers? Yeah. Yep. Those look like the same decimal answers. Go ahead and study his solution. If you like it better, go for it. Example 5. There's the original problem. And if I would have just written it out, I would have said to myself, I don't know what to do to both sides. Because if I try to pull it all on one side, like I told you, tangent of x plus square root of 3 minus secant of x equals 0, that really doesn't look like it means anything to me. So that way isn't exciting. And he gave me a hint up here by squaring, and I'm not even positive I would have seen that. But there is an advantage of it. I don't have any identities for tangents related to secants. But I do know something about secant squares and tangent squares. So that's why he gets paid the big bucks, because he thought ahead about secant squares and tangent squares. We have an identity for that. If I square both sides, I have to remember to treat this as a tangent of x plus square root of 3 times tangent of x plus square root of 3 equals to the secant squared x. We're in radians, and I left a note here for me. This is mostly for me, not for you. Be careful, we will have to check the solutions. Whenever we're squaring both sides, not every solution is going to be one that we want. There might even be something called extraneous solutions that don't even work. So this was really a note to me, to make sure you check the solutions at the end when you do something as crazy as squaring both sides. With that being said, let me continue this problem. Tangent times tangent will be tangent squared x. Tangent times square root of 3 and tangent times square root of 3, they add together, making 2 tangent square 3's plus square root of 3 times square root of 3 is square root of 9, which is just a 3, equals to a secant squared x. Now, I left this note for me too. Pythagorean identity. Do you remember your Pythagorean identity with secant squares? Because look at tangent squared, tangents, and here's this oddball called secant squared. It would sure be nice if I could rename secant squared with tangents. I'll let you think about it for a minute. Go look at your notes. Did you find it? If you forgot, do your Pythagorean identity. Remember, the Pythagorean identity we had was sine squared plus cosine squared equals to 1. And if I have a secant squared, that's a 1 over cosine squared. So divide everything by cosine squared. Divide everything by cosine squared. Cosine squared. Sine over cosine is tangent. Cosine squared over cosine squared is a 1, and this is, see, so you got a tangent squared plus 1 equals to a secant squared. Tangent squared x plus 2 tangent x square roots of 3. You know what? Let me put that that number. Tangent of x is multiplied by square root of 3. So why don't I put that 3 in front? This is tangent of x times the square root of 3. So it's 2, erase some more. 2 square roots of 3 tangent of x. There's 2 of them. That looks better. Plus 3 equals to 1 plus tangent squared x. I like it better because they're all tangents. Now get everything on one side, see what happens. If I subtract 1 from both sides, that becomes a 2. If I subtract a tangent squared x, I subtract a tangent squared x over here. That cancels, that cancels, that cancels. That becomes a 2. I'm left with 2 square roots of 3 tangent of x plus a 2 equals to 0. Well, that looks a lot simpler. Get everything on one side. Tangent of x equals to the negative 2 over 2 square roots of 3. The 2's cancel. I'm left with a negative 1 over square root of 3. That looks familiar. I've seen square roots of 3's with a 1 before. The problem is, let's see. Yeah, tangent is opposite over adjacent. And what triangle and it's negative, so I gotta be careful. Where's tangent negative? Tangent's negative here, tangent's negative here. There's my x, there's my x. I want 1 over the square root of 3. Opposite over adjacent. Opposite over adjacent. This opposite's negative, this opposite's negative. This, ooh, I messed up. Tangent's not negative in both those quadrants. So if you're paying attention and you go and you write your signs now, I realize that this one in quadrant 4, tangent is negative. But tangent is not negative in quadrant 3. It's got to be in quadrant 2. 1, negative square root of 3. And that's a 2, and that's a 2. Okay, now that I messed up and I found my mistake before you did, what triangle am I looking at? That's a 1, 2, square root of 3 triangle. The hypotenuse is being 2, the longest side. I hope you see it, that x is really a 30-degree angle. So if that's 30, and my domain of this problem was between 0 and 2 pi, I'm not going to use negative 30, because negative 30, yes, it works, but it's not in the domain. So I got to take 30 away from 180. That's 150 degrees, but I got to do it in radians. So since all the way across, how many 30s are there? There are 6 of them. Take away 1 of them. So one of my answers is 6 pi over 6's. Take away 1 pi over 6 is 5 pi over 6. And the other answer is, this is 12 30-degree angles. 12 30-degree angles, because 12 times 30 is 360. So that must mean 12 pi over 6's. Take away 1. 11 pi over 6's. Wow. What a monster. Now, I was just going to go ahead and move on and say, let's check the answers. Let's make sure those answers work. Because I left this note for me, not for you, because I'm the one that will forget it. The original problem, how do we check our work? Original problem was tangent of x plus a square root of 3 has to be a secant of x. You can always do this, by the way. You can always check your solutions, make sure they're good. Let's plug it in here. Tangent of 5 pi over 6 times or plus the square root of 3, is it equal to the secant of 5 pi over 6? Well, we did 5 pi over 6. Tangent of 5 pi over 6 was here. That tangent is a 1 over the square root of 3, negative square root of 3. So that's negative 1 over the square root of 3 plus the square root of 3. It has to be equal to the secant of this same angle right here. Secant of x is 1. Well, let's do it with the sides of the triangle. Cosine of x is adjacent over hypotenuse. Therefore, secant must be hypotenuse over adjacent. That's 2 over the negative square root of 3. 2 over negative square root of 3. Okay, I'm keep going. Let's add these two fractions together. multiply by square root of 3 over square root of 3, or do the magic cross multiply stuff. That gives me a negative 1 plus 2 square roots of 3 all over square root of 3 has to be equal to negative 2 over the square root of 3. Let's see. Well, was that true or not? Let me multiply both sides by square root of 3 to see what happens. To get rid of that. Square root of 3, square root of 3, gone, gone. Negative 1 plus 2 square roots of 3, is it equal to a negative 2? It can't be, because this would have to be equal to a negative 1. So I think if I did this right, that answer doesn't work. If I'm correct, that's extraneous. Let's try the 11 pi over 6. Original problem is tangent of x plus the square root of 3 has to be equal to the secant of x. This time I'm using 11 pi over 6. Tangent of 11 pi over 6 plus square root of 3 has to be equal to the secant of 11 pi over 6. So now I'm in this quadrant here, using that one. Tangent of that triangle was a negative 1 over the square root of 3 plus the square root of 3 has to be equal to the reciprocal of cosine. Cosine is adjacent over hypotenuse, so 2 over square root of 3 would be the secant. 2 over the square root of 3. Let me make this, let's see, what would be the easiest thing to do? Let me multiply both sides by square root of 3, just to get rid of this denominator. Gone. Distribute this, gives me a negative 1, plus square root of 3 times square root of 3, square root of 9 is 3. And that gives me a 2. Let's see. 2 equals to 2. That answer works. That means I only have one solution. Wow. That's pretty awesome. A lot of work. You need like 2 pages of paper. You need to get ready because you can make a mistake. It is a lot. If I were you, and I'm correct, I haven't even looked to see if I'm right, do this problem by yourself 2 times till you understand every detail. Let's see. 2 possible solutions. Yay! Since we found it by squaring both sides, we must check each. 5 pi over 6 is not a solution. His is a little different method that he used. Yeah. Oh, yeah, that's a question. I was wondering, what was this? It's just question mark. So he crossed that out, and there it is. Yay! I feel so happy. When you solve a trig equation, decide whether you're working with linear or quadratic form, and try to do whatever method you know how to do. If only one trigonometric function is present, just solve it. If you got more than one, you got to use identities and stuff to try to get it equal to each other, or equal to 0. If it's not factorable, use quadratic. Check the solution. Yeah, we should always check them, but I get lazy. Use trig identities to, yes, okay. Ready for another one? Okay. You knew it was coming. Half angles. Oh, wow, this will be fun. Because look at, there it is. There's our half angle. So I suppose you need to have those identities memorized. 2 sine of the half angle of 2, x over 2, that's a half angle of x, I'm sorry, equals to 1. he says, find the solution from 0 to 2 pi, and then how would you represent all solutions? So, I kind of like what he did. If we're going from 0 to 2 pi, he divided everything by a 2 to get my domain is really going to be of x over 2 is really going to be from 0 to pi. That was, I've never quite done that before. That's an interesting approach. But anyway, moving on. Here's my problem. 2 sine of pi over 2, or I'm sorry, x over 2 plus 1. Divide both sides by 2, you get sine of x over 2 equals a half. Well, here's what I tend to do. Sine of what is a half? Hopefully you remember that a 30-degree angle opposite over hypotenuse, that being the square root of 3 down, that will be what we're talking about, a 30-degree angle. So this what is my is my angle. So x over 2 must be a 30-degree angle. But we have to solve for x. So x must be a 60-degree angle. Chew on that for a minute. So if I graph my solution here, (60 degrees, which is pi over 3. And that's my x. Think about it. That means positive. Where else is sine positive? Over here. So if that's 60 degrees, then this is 60 degrees. That must mean 180 minus 60 must be really what this angle is. So x should be written as the pi, I write pi over 3. And this 1 pi over 3, 2 pi over 3, that gives me 120. So this must be 120 degrees. What did I just write? 180 minus 60 is 120 degrees. That's right. Which must be 1 pi over 6, 2 pi over 6. I mean 3, not 6. 2 pi over 3. That wasn't bad. I thought we were going to have to use an identity. We really didn't have to. Or not the way I used it, at least. Let's see how he did it. How would you answer all solutions? You just go around 360 degrees from this answer, adding 2 pi to this answer, adding 2 pi to this answer. So all solutions would be 2 pi times some number of rotations plus pi over 3. The other one would be 2 pi times some rotations, whatever number you want, plus 5 pi over 3. Okay. Definitely, if you go 4 pi, that's 2 times around. I have to get back to you if my answer 2 pi would give you correct solutions. I will take his example. I will chew on that tonight, but I don't have a good explanation why the, oh, 3, okay, the odd numbers won't work. The odd numbers won't work because we had half angle. You're not going completely around if you take half of 3. You won't go all the way around. That's why. Okay. Or I can sleep tonight. Have to be even multiples. So it's going to be 2, 4, 6, 8. Yeah. Yeah, you did pretty much the same idea. Now, let's see. We have to do B. To do B, what I would do. Oh, he has something different. He's going around 4 pi. Oh, because of the fact that he has to go around double. I think he actually uses calculator too. Okay, 7. Double angle. And you see how it's written right there. That's a double angle. So you need your double angle identities because this is a single cosine. This is 2 angles. The angles aren't the same. X does not equal 2 x's. So what happens is you cause a problem. So the best way is to get single x's. So you have several identities. The first one that we figured out, remember when we did cosine of A plus B was cosine A times cosine B minus sine of A sine of B. And then that's cosine squared. No, it's not because it's not the same. If it was cosine of x plus x, which is that's what this is, that gives you cosine x times cosine x minus sine x times sine x. That's cosine squared x minus sine squared x. And then we did what? That's one of the identities we could have used. To get this one, substitute, let's see if we want it all in cosines. What's an identity for sine squared? Cosine squared x minus 1 minus cosine squared x. Cosine squared x minus 1 plus cosine squared x. That's 2 cosine squared x is minus 1. Will equal to cosine of 2x's. So that's the one he's using. Again, we could derive it every time we need them or memorize them. Questions? Of course you have questions, but if you don't send them to me, I can't answer them. Let me erase all of this. Did not need any of this technically, but it was just to show you that we did do those identities before. And you know what? It's always good to review where this stuff comes from. So we're going to use this identity right here. That means in place of 2x, I'm going to write cosine of 2x is really cosine squared x minus 1. So this is 2 cosine squared x minus 1 equals to cosine. Doesn't that look like a quadratic situation? It certainly is. I'm glad you said that. So it's 2 cosine squared x minus cosine x. Bring it all on one side. Minus 1 is 0. And if it factors, it would be great. If it doesn't, quadratic formula, with a being equal to 2, b equal to a -1, and c equals to a -1. But I hope it factors. I hope if I'm doing 2x squared minus x minus 1 is 0, let's see if it factors. Please, 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 please. I need a 2x and an x. I need a 1 and a 1. It's the only way I'm going to get a 1. Let's see, 2x minus an x is a positive x. Minus here, -2x plus an x is a -x. Ah, there it is. So that gives me, remember, everywhere you see the x, it really meant cosine of x. Right here, that's x. That's x squared. So it's going to be 2 times cosine of x plus 1, 2 times cosine of x. No, it isn't. That's not a 2, that's just a cosine of x. Minus 1 equals to 0. X could be a -1/2, and x could be a 1. There are two angles where why am I writing that? Cosine of x is a -1/2. Cosine of x is a 1. Where is cosine negative? Here and here. We don't want the negative angle because he's only going from 0 to 2 pi. So what angle is cosine equal to a half? Wait, he said negative. Why am I putting one here? Wow, I always hate that. Cosine's negative, sorry. Here and here. And if I zoom in on one of them, there's my x here. Here's my other x. -1/2. This must be a -1. Adjacent over hypotenuse. Adjacent over hypotenuse. Those are my two angles. 1, 2, square roots of 3. This one must be a negative square root of 3. Not that it matters. What angle is across the street from the square root of 3? A 60-degree angle. Because across the street from a 30 across the street from a 1 was a 30. So we're looking at a 60-degree angle. So if this is 60, or pi over 3, and there's 3 pi's over 3 till you get to pi, this must be a pi minus a pi over 3, which is a 2 pi over 3 is one of my answers. And then this is another 60 added to the 180, or should I say pi plus a pi over 3, which is 3 pi over 3 plus a pi over, that's 4 pi over 3. So there are my answers. The solution set, x is 2 pi over 3 and 4 pi over 3. And I'm lazy. I don't always check my answers, but it probably would not be a bad idea to check them. I cannot guarantee you that both of those work. Pick up your calculator and just check it out. 2 of these cosine, is it the same as one of them cosine? I'm just going to press that they are, and if they're not, it was your job to check them, not mine. Oh, why didn't you tell me I didn't finish it? All I did was this side. All of this. Hello. Forgot to do this side. Cosine of x equals to 1 happens where? Right here. It's only place. 0 radians. So let me adjust my solution set. And squeeze in the 0. comma, 2 pi over 3 and 4 pi over 3. It's in there. Okay. 4 pi, okay, right here. Oh, what? A 0. There's a 2 pi and 4. What happened? Oh, I didn't finish the problem. Oh, well. Can't win them all. I mean, heck, man, we just did. I'm actually think we've done enough. You could probably do the whole assignment. 4 sine. Oh, I saw that before. Remember, 2 sine of theta cosine theta is the double angle of sine. I remember that. So take out a 2 to make that a 2 times a 2 of this. So you have 2 times the sine of 2 theta equals to the square root of 3. And the reason I would want to use an identity is these two trig functions aren't the same. But by using the double angle identity, I don't have to worry about it. So how do I do this? Solve it for sine of 2 theta. Sine of 2 theta equals square root of 3 over 2. Where have I seen that before? It's positive, so where is sine positive? Draw my triangle over here. Opposite over hypotenuse, square root of 3 over 2. That's a 1. This angle here is 2 theta. Wrong marker. 2 theta. And we're in degrees, so 2 theta is equal to 60 degrees. Also, over here, 2 theta over there would be 180 minus 60, because this is still square root of 3. This is still a 2. That's 120 degrees. But wait, there's more. If theta is from, let's see, theta is greater than 0, but less than 360, that's my interval here, that actually meant 2 theta would be times 2 times 2 times 2, 0 less than 2 theta less than 720. So I got to keep on going. So I got more quadrants to fill. I've got to go around that circle. If this is 60, I got to keep on going because that's only 360 degrees. I got to go another 360 around. So 30 plus 360, not 30, was 60. 60 plus 360 is 420. And 120, another color, this was the 120, but it has to go around again because my domain went all the way to 300 or 720 degrees. So that's 420 plus 360 degrees, 780 degrees. So I actually got 1, 2, 3, 4, that is 2 theta. But I don't want theta. So I divide everything by a 2. Theta solution set will be 30, 60, 210, and I don't know, what's 780 divided by 2, that's a 3. 90? I have to do the math again. I gotta pick up my calculator and see. Did my math wrong? This was 120. Oh, plus, what am I adding to that for? Was 120 plus 360. That was this one. Well, that was that 120 plus 360 is 480. That was 480. Half of that's 240. Okay. 240. Okay. A lot of little dotting your P's and Q's, and it does get confusing. My head's starting to hurt. Okay. How many more we got left? If you were in my room, oh, that's the same problem. I'm not doing all solutions again this time. Take a look at them. They're adding 180 to every answer. I'm not going to do it. Number 9. Describing a musical tone from a graph. A basic component of music is a pure tone. The graph below models the sinusoidal pressure Y equals P in pounds per square foot from a pure tone at time x equals to t in seconds. So we got this sinusoid that's been traveling, and it looks like he's traveled for the x is 0.04 seconds. And we can tell that the amplitude of this sinusoid is 0.004. So the height is 0.004. And he said it's sine, so here we go. We're starting here. What do I have to know? I don't know what he's asking. Okay, I'll just talk. Let's see what he's asking. The frequency. The frequency is measured in hertz. 1 hertz is equal to 1 cycle. Oh, okay. 1 cycle means if I start here and I go, that's 1 cycle. Starts over again. Here's 2. Start over again. Here's 3. Start over again. 4. 5. 6. He did 6 cycles. He did 6 cycles. The time for the tone to produce 1 complete cycle is called a period. That symbol is called tau. It's a Greek symbol. Approximate the period. Well, period is how long 1 cycle went. So we know we had 6 cycles. We just counted a minute ago. So we take the total time he traveled those 6, divide it by the 6 cycles. That'll tell us how long it took for 1. So tau is equal to 0.04 seconds for 6 cycles will give us the number of seconds per cycle. And he did the math for us. 8b. Okay, it's the same graph. The equation of the graph is y equals 0.04 sine of 300 pi x. That is the same graph. Use your calculator to estimate all solutions of the equation that makes y equals to 0.004. Well, that was the height. So to use a calculator, I'm going to put y1 to be this one. y2 will be that line, y equals 0.004. And I'm only going from 0 to 0.0, how long did it take me? 0.04 it was, I believe. And then what we'll do is we'll find all of the answers. You do it, I'll do it, and we will compare our answers. So I'm going to get this ready for my calculator. Be right back. Okay, did a lot of graphing, took a lot of pictures for you to look at. So we're only looking for 3 intersections. And let me show you what I did. First thing I did, typed in the function. Next thing I did, set my window. Since I knew my x's were only going from 0 to 0.04, I went a little below and a little below and that's a negative, and a little above. I knew the height, the amplitude was only 0.004, so I went a little above and a little below. That's how you see the picture. Oh, you didn't see the picture yet. You will see the picture. See this? There it is. Now, I'm showing you all of them. I'm showing you, 1, 2, the wrong color. 1, that's 2, 3, 4, 5, 6. Okay. Now his picture in the thing is he only showed you up to the 3. So I could have changed it up a bit, but I wanted you to see it. Then I typed in the horizontal line that I want to find intersecting it, and that was y2 is 0.004. Hit graph again. There it is. You see it's this horizontal line. Use trace or use find the intersection to find those 3. There's the first at 0.0016. Let's see, did he find that one in his? He rounded it up to 1.7. That's fine. And then the next one, let's see, where was I at? There's the 0.0017. That's so he went to 4 decimals. Next one, 0.0083. That stays 83. 0.0083. Let's see, did he get 0.0083? There it is. Last one's 0.015. Let's see, 0.15. I'm pretty sure I had it right if those were right. Third one, 0.015. Okay. So you practice using your calculator. Took me a long time to put those and paste them in there, but you guys are worth it, so I did it. Frequency of fun of piano keys. Guys, I'm going to let you read this. It's interesting, but man, I've already been on this long enough. So I think that's it. That's it. Now, my math lab has been there since this morning, so has these lecture notes been there this morning. Now I just got to save this and